Hi everyone, we're now going to solve multiple angle trig equations. These might be more accurately called multiples of angles. We're going to solve equations like these. 2 sine of 4x is equal to negative root 3. And I must tell you that personally, I think books often do a horrible job of teaching this section. I think the key solution here is substitution. That's a key trick here, to use a substitution. Now, we could isolate the sine expression first, divide by 2, right? Sine of 4x equals negative root 3 over 2, which, by the way, is a known sine value. And let's do a substitution. I'm used to thinking of angles being like theta, but if you want to use u, that's fine. I'm going to substitute theta, or u, equals 4x. And I now want to solve this trig equation for theta. Solve this for theta for now, which is a standard linear form problem. All right, so let's think in terms of theta. Theta is the angle. All right. Well, old school. In what two quadrants is the sine value negative? Think y-coordinate here. In quadrants 3 and 4. But it might be helpful to find the reference angle in quadrant 1. I'd like to know the inverse sine of positive root 3 over 2. So the sine, I'll put this in blue. The sine of what famous angle is positive root 3 over 2? The sine of what famous angle is positive root 3 over 2? The arc sine of root 3 over 2, think high point, is pi over 3. Pi over 3. Okay. We're looking at this high point over here. Now, pi over 3 itself is not a solution for theta in this equation because its sine value is positive root 3 over 2, but it is the brother. It's the reference angle for all the solutions. And so we basically want all of the brothers that are in quadrants 3 and 4. The most famous positive representatives for these 2 points are 4 pi over 3 and 5 pi over 3. Now, it's true that instead of 5 pi over 3, we might have preferred negative pi over 3 before. But see, in a follow-up example, we're going to find the solutions between 0 and 2 pi. And if that's going to be the long-run goal, I'm actually going to want a positive twin over here. So if we want the solutions between 0 and 2 pi, eventually, and that is my follow-up example, then I may actually prefer the 5 pi over 3 to the negative pi over 3. Although, in terms of this general solution, negative pi over 3 may be more convenient if you do want all real solutions for theta here, which eventually will get us all real solutions for x over here. All right. So if we take these 2 representatives for these 2 points, then we get the solution set for theta. Okay, we get the set of all real values of theta of the form 4 pi over 3 plus 2 pi n, because we want all the coterminal twins, where n is integer. Or theta could be of the form 5 pi over 3 or negative pi over 3 plus 2 pi n, where n is integer. I want a representative for this quadrant 4 point and all the coterminal twins. But are we done? Are we done? No, because these are our solutions for theta. But the original equation is in x. We need to solve for x. Still, this is a good intermediate step. What's the relationship between theta and x? Theta equals 4x. So let's perform this sort of back reverse substitution. We're going to go back from theta to 4x. And in fact, as you do your work, you might just want to write 4x under the theta so that you don't have to repeat these right-hand sides over here. Theta is 4x. We're going back to x. We eventually have to. So now we have, down here, 4x equals all this, or 4x equals all this. And we now have to solve for x. Solve for x. All right. In both of these equations, these cases, how do we solve for x? In both equations, we divide both sides by 4. Now, on the right side, instead of thinking of dividing by 4, instead of thinking of dividing by 4, we might want to think about multiplying by what number? Dividing by 4 is equivalent to multiplying by what number? Multiplying by the reciprocal, namely 1/4. So when dividing the right-hand side by 4, it may actually be more convenient to think of it as multiplying the right side by 1/4. All right. Now in my notes, I actually do divide all the terms on the right sides by 4. But again, it might be more convenient to think of multiplying by 1/4. So over here, 4x divided by 4 is x. That's fine, all right? But what's all this divided by 4? It might be easier to think of it as what is 1/4 times 4 pi over 3? When you take 4 pi over 3 and divide by 4, you're really multiplying by 1/4. And then what happens? Goodbye. We have 1s left up here and down here. We're left with pi over 3. Pi over 3 plus, well, 2/4 is 1/2. So 2 pi over 4 is pi over 2 times n. You could write this as pi n all over 2. As it turns out, partly for theory purposes, I'm going to pop the n out. But if you want to leave the n up on top, that's fine. All right, over here, in case 2, again, we divide both sides by 4. On the left, it's easy. 4x becomes x once again. But on the right-hand side, again, we might want to consider multiplying by 1/4. 1/4 times 5 pi over 3, which is easier to think of than this. 1/4 times 5 pi over 3. We don't get any cross cancellations or anything. We just multiply across. We get 5 pi over 12 over here, 5 pi over 12. Plus, and we have this same last term over here, we get pi over 2n. We start off with 2 pi n in both cases. We end up with pi over 2n in both cases, where n is integer. At the very least, put this at the very end. Technically, I should carry it through here, but remind me at some point. So finally, in fact, we could put this over here. Finally, we have our solution set. All right, our general solution set for the general equation, meaning that I'm solving over all reals. The solution set is the set of all x in the reals, such that x is of the form pi over 3 plus pi over 2n, or x is of the form 5 pi over 12 plus pi over 2n, where n is integer. So that's my general solution. It's the set of all real solutions for this top equation over here. Now, a natural follow-up example would ask, what are the solutions for this equation between 0 and 2 pi in this interval from 0 to 2 pi? Believe it or not, that's actually a much harder question for students. And in fact, even if I were to ask this right off the bat, my suggestion is to find the general solution first. I advise that you find this general solution first anyway. So whether I ask for all real solutions or just the solutions between 0 to 2 pi, I advise that you find this general solution set first. In the next video, we're going to find the solutions between 0 and 2 pi. And we're going to find out why it's actually more work. And in fact, we're going to need to build off of our answer to this first part. That's in the next video.